Yeah. Okay. Oh, you sad wizard. Where's that?
Okay, here I am. Okay, so sorry about that. I wanted to say welcome to everybody this morning, and so glad that you are here to join us. And this morning we have a lot of interesting things for you, and so we have a guest speaker, which we'll get to in a bit. In the meantime, if this is your first time here, if you could kindly make sure that you put the county that you're from and how many people are with you. So even if you're an individual, that's fine. If you could just in the chat box put what county you're from and your name, that would be great. The next thing that we need to look at is if you have had an iPhone, iPad, iTouch, some of the things you won't be able to do. It's great that you're here, but if there's any interaction with shared applications, you won't be able to do that, or interaction with whiteboards. So when we do the map, you probably won't be able to put your thing on there. And then also anything that is up here that you see that you won't be able to do. But being able to participate, you can ask questions and enter things into the chat. That's really great. So please participate that way. This is who I am, and so if you need to get a hold of me, there's my email and my phone. Glad to talk with you anytime. And so we've got a few things left that we're going to cover. Then Dr. Sara Villani will have a presentation for you. Then I think it's reversed. I think it's Matt and then Mike today. And then we've got an update. Typically we have Mark Blevins, who's not able to join us today. So if you visit another time, you may get those showstopper plants that he shares with us. All right, and so Matt and Mike are both from the Plant Disease and Insect Clinic, and I would encourage you to visit this site because this is where folks can log into the database, and the agents have done that. But there's also a lot of great resources here, so I encourage you to visit this site. All right, and so you can see Mark Blevins won't be with us today, but we have Matt Bertone and Mike Munster, and so both of these wonderful gentlemen will be here today sharing information. If you have registered for Extension Master Gardener College coming up, they're offering a hands-on workshop, which is already filled up, which is amazing to me. It's great that that has happened right off the bat. Okay, so if you have not been here before, there's a few things you need to know. First of all, and I'm not sure if you can see my hand or not, but you can see who's talking in this spot right here. If you are someone who has a microphone, when we get to the point of asking questions, you can click talk, but when you're done asking your question, please turn talk off, because if we have too many people on, we can all sound like chipmunks, which sometimes happens anyway. This is where you would see your chat show up, and this is where all the participants are located. This is where the presentation will show up, which is what you all are looking at right now. There are some things in the toolbar that we just won't do. But if you also have sometimes when Mike comes on, he'll ask you a question to check, and so you can check off here if you can hear him or whatever he asks, so that you know where that is. Anyway, let me move on. All right, so we've got our intro. We won't have the showstopper plants. We've been through all of this. And what I would like you to do is, if you guys can, if you're looking over here, you'll see a little star show up on your bar there. If you could, star, smiley face, any of this other, you could pick whichever thing you want to put, but if you will mark where you're from in your county so we can see where you are. Well, that is great. We have all the districts represented. That's wonderful. Okay, so thank you. And we will move forward. Okay, so Dr. Sara Villani will be with us today, and so she actually is going to have a great talk, which will come up next, but I wanted to introduce you to her. She's an Extension Assistant Professor of Apple and Woody Ornamental Pathology, Department of Entomology and Plant Pathology at NC State. She's been to Cornell, got her PhD in 2015, and I tell you, they're at Venturia, defining practical resistance to single-site fungicides in Venturia inequalis. And since arriving at NC State, she's focused her research efforts on understanding the biology and epidemiology of, I'm sure she will pronounce this for me, Colotrochicum, pathogens of apple, and evaluating fungicide sensitivity. So you can see where she's going to be, this is going to be a great presentation, especially for people who are fruit producers in their own orchards and dealing with diseases there. So at both Cornell and NCSU, she's been an author of 13 peer-reviewed publications, 40 technical and extension publications, and over 60 extension or applied research presentations. So her applied research program provides synergy with her extension appointment with an overall goal of improving disease control in apples with improved fungicide stewardship. So, Dr. Villani.
All right, thanks, Lisa, and I appreciate you for inviting me here today. So today I'm going to address disease identification and management in the home orchard. And I've had a lot of homeowners and extension agents come to me regarding issues in the home orchard. A few weeks ago, I had a class from Brevard College who is starting a new plant protection or sustainability program and wanted to plant an apple orchard. They wanted a perennial crop. And I'm afraid I might have scared them away a little bit, actually, from growing apples. But hopefully that's not my goal today. And I just want to address some of the challenges to growing apples, especially here in the Southeast, and how to identify some of the diseases you might come across in a home orchard, and really how are we going to deal with those diseases. So I'm going to start my timer here. I promise not to go more than 20 minutes. All right, so let's start with, what are some of the apple disease challenges that we're facing here in North Carolina and really throughout the southeastern United States? So as Lisa said, I'm from New York originally, and we had a number of diseases to contend with there, but I've never seen the number of diseases in my first year at NC State in apples. And so just to go through some of these diseases here, diseases, pathogens of apple can attack pretty much any tissue. Nothing is left unscathed. So they can infect roots, they can infect the scion or the trunk up here, the rootstock area of an apple tree. Of course, they can infect the fruit and the leaves. So just to go through some of these diseases that you might encounter in a home orchard, and we'll get more familiar with those as this presentation goes on. This here is apple scab on a mature apple. Going down here, this is white rot. The bottom left-hand picture is white rot, and we usually see that either toward fruit maturity in the orchard or post-harvest. Continuing across the top now, I've seen a lot of cedar apple rust. I was out toward Raleigh last week, and cedar apple rust has been a considerable problem, and we'll talk more about that. Fly speck sooty blotch is the next photo on the fruit there. That long vertical picture that you see, that is ooze coming from a fire blight infection in the rootstock, and we'll talk a lot about fire blight. That's the first disease we'll cover. I had mentioned white rot. Powdery mildew, which you see a lot, you'll see that on roses, lilacs, etc. Well, apple has its own special powdery mildew pathogen, and this is what we call primary mildew, which you might start to see coming in orchards right around now. And the photo with the fly on it, that's bitter rot, and that's usually identifiable by the salmon-colored spores in a concentric ring, usually on mature fruit of apple. So many, many diseases. This is just a quick snapshot of them, but we have many others that we have to manage throughout the growing season. All right. Another challenge that we have is that we really do have a paucity of disease-resistant cultivars that I can recommend. And a big reason behind this is that efforts from apple breeders are really focused on consumer preference. So if you go to your Lowe's food store or your Ingles or your Publix, normally you'll see the typical apple cultivars like Cortland, Macintosh, Empires, and consumers have their preference for these cultivars. Whereas if you go to a grocery store, you really only see one, maybe two types of strawberries. And so that consumer preference for variety is just very important in apples. The other issue with breeding resistant cultivars for apples is that usually these cultivars are only bred for single disease resistance. So in the previous slide, I had shown you all the diseases that an apple tree is susceptible to in any one growing season here in the southeast. Well, usually when breeders will breed for resistance, we'll see maybe an apple scab resistant cultivar, but it will still be susceptible to a number of other diseases like cedar apple rust or powdery mildew and so forth. So as you see in these pictures here, these are a number of cultivars that are resistant to apple scab, and often you will not see any of these cultivars show up in the grocery store. So they're just not very popular amongst consumers. Okay. Another challenge that we have in the southeast, of course, is our warm and humid climate. And so we're all familiar with the disease triangle that I'm showing here. What we have is what we need for a disease or infection to happen and disease to show up is we need a host. And not only a host, first of all, we need a susceptible host. So right here I'm showing open blossoms and new tissue starting to come out from a shoot. So these tissues would be susceptible to fire blight. Whereas if this blossom was still in pink bud, yeah, we have a host, but if the blossoms were closed, the host would not be susceptible to fire blight. Okay? Of course, we also need the availability of the pathogen, and to the right there, we need a conducive environment for disease. So really, especially up here in the mountains, so with warm, humid temperatures, and even the wind that we get to move spores around is really presents a challenge for disease management here in North Carolina on apples. Okay. So there's that. Oh, also I wanted to mention that another concern we have is not necessarily the environment during the growing season. We also have to consider the environment toward the winter. So the mild winters that we've had here really present a challenge with inadequate chilling hours. So when we have inadequate chilling hours, what will happen is we'll have a staggered bloom period, which means that we have a longer period of susceptibility to things like blossom infection in fire blight here. Okay. And finally, the last challenge that I see for managing apples here in the southeast is really maintaining good practices of fungicide resistance management and meeting maximum annual application allowances of fungicides. So this is, we can see here, these are the multi-site protectants that we have for commercial control. These are the single-site fungicides, which attack a very specific area of the fungus. And then we also have biologicals as well. But growers here in Henderson County had to apply up to 24 applications of fungicides in 2017 alone. So the real challenge is, how can we rotate these single-site fungicides, which are very prone to resistance development, and still maintain good control of our pathogen? All right, so let's go ahead now and transition to some of the diseases. Luckily in apples, the primary bacterial pathogen that we need to be concerned about is Erwinia amylavra, and that pathogen causes fire blight in apples. What's so devastating about this disease is that it can cause infection in blossoms, in shoots, and really in the rootstock area and in the scion of the tree. So again, pretty much every tissue in an apple tree is susceptible to fire blight attack. And let's go in a little bit further on how this disease develops. Okay. So what will happen is your pollinator, but these bacteria, let's start back again. So these bacteria with some heat will multiply and hang out epiphytically on the stigmatic surfaces of blossoms. Now, of course, this is also during the pollination time. So as your bee or your pollinator is working on pollinating the flowers, they'll inadvertently pick up some of these bacterial cells and bring them on when they're pollinating another blossom area. With some heat units, the bacteria will multiply until they get a very, very high population on a flower. Then, once we get some rainfall or some dew, that bacteria will be washed down into the nectar thodes and create an infection. So again, it's not just the bacteria on the stigmatic surface of the apple, of the blossom, that causes the problem. You also need a rain event to wash those bacteria into the flower. So what are some symptoms of blossom blight, the blossom blight stage of fire blight? So if you go out in the morning, you might see a little droplet of ooze on the flower after petal fall. This little droplet can contain millions of bacterial cells, and this is often indicative of a blossom blight infection. You won't see this if you go out usually on a rainy day or a windy day. The ooze droplet will not be there. So if an insect was to pick up this little propagule or this little ooze droplet, like I said, this can have millions and billions probably of bacterial cells that can then be transmitted to other flowers. Another sign of fire blight or blossom blight is if you look in the bottom right-hand corner right here, this is from an experiment, an inoculated experiment that we did back in New York. And you can see basically that all the petioles are black in there. This is a pretty severe infection. And in some cases, once you have petal fall, you may not be able to tell if this is actually just a normal floret or if it's infected with blossom blight. If you give it a gentle tug, the floret there, what you'll find is that those that are infected with blossom blight, because of the bacteria, they're sticky, and they'll be really, really difficult to pull off. So you'll have a hard time pulling off an infected flower from the blossom cluster. Okay. Fire blight is also responsible for a shoot blight phase of the disease. And you'll see this quite often in orchards. What you'll see and what's distinguishable here is a shepherd's crook, sort of like Linus there during the Charlie Brown Christmas special. So you'll see blackening or necrosis also of the midvein. I didn't put a great picture here, but the pathogen will move through the xylem and along the midvein. So that's one way to tell if you have a fire blight infection in your shoots. Now, if it's left uncontrolled, this fire blight will move down into the main scaffolds and toward the trunk. And that is what the photo on the right-hand side of the screen is showing you. And this is a problem for a number of reasons. First of all, it'll reduce bearing wood for the next season. And secondly, once you get into the scion of the tree or the trunk of the tree, it's pretty much game over for the tree. There's not much you can do about it. Okay, just another couple phases of fire blight that you should be aware of. On the top picture here with the red circle, this is canker blight. And this was caused by a shoot blight infection the previous year. Okay, this is usually distinguished by a water-soaked zone in healthy tissue bordering cankers, or in this case, really, you will see a blackened branch separated by healthy tissue. This separation occurs because older wood, second, third-year wood, is much more resistant to the fire blight pathogen than first-year wood or new wood that's out. Okay. There's also, like I mentioned, rootstock blight, and once it gets into the rootstock, again, it's game over for the tree. Why? Because the tree can no longer take up its water and nutrients because the bacterium is clogging the xylem of the tree. This is often managed with resistant rootstocks. And then there's even trauma blight. So even after a hailstorm in the middle of the summer, we worry about fire blight because that creates a wound for the bacteria in which to enter. Okay, so how are we going to manage fire blight? So remember those cankers that I showed you in the previous slide. Those cankers are where the bacterium overwinters. And so what you want to do, and what you want to tell your homeowners to do, is you want to prune those cankers at least 12 inches from the infection margin. You want to go so far back from that margin because even though we don't see symptoms, the bacteria is usually progressing further than what our eyes can see. When you prune, the best time to prune is when the pathogen is not active. So really during the late winter is the most ideal time, any time in the winter, but we usually recommend the late winter to our commercial growers. If a homeowner or if you want to go ahead and prune because you see a strike during the spring or summer, make sure you do it on a cool and dry day. And then of course you want to take all of that wood that you've cut and move it away from the trees and destroy it somewhere. As I mentioned, there are some resistant rootstocks, so that's the bottom part of the tree below the graft union. So there are some resistant rootstocks. Unfortunately, most of those rootstocks are for high-density orchards, which you see here in the right picture. So I don't usually recommend dwarfing rootstocks for homeowners. They're difficult to manage. Fire blight can enter the scion or the trunk area much more quickly, and they're just more labor-intensive. There are cultivars of apple that tend to be more resistant. If someone tells you they have a resistant fire blight cultivar, don't necessarily believe them. So, but there are some, like Goldrush here or Jonifrey, that are much better options and have much higher tolerance for the fire blight pathogen. Okay, and then of course there's chemical management for fire blight. And this is to really attack any of those three stages that we see it. During the late dormant to early green tip stage, you want to go ahead and apply a copper product. And you're doing this to put residue on the tree to protect from when those cankers start to ooze. You want to be careful applying copper past green tip because it can cause phytotoxicity to the tree. During bloom, I usually recommend streptomycin. It's an antibiotic, and it's marketed for homeowners as Agristrep. Sometimes it's difficult to find, though, but that's our standard for managing blossom blight. Your other option is to apply copper plus mancozeb. Be careful during this time, though, because, again, we start to worry about phytotoxicity. Around petal fall, we need to start worrying about shoot blight control. So, again, copper for the homeowner is really your only option. But I've shown you here in this bottom right-hand picture what applying copper during bloom through petal fall can do. It can cause pretty severe russeting or phytotoxicity of your apple. Okay, I want to get into a few apple diseases that a few fungal diseases of apple that might show up in homeowner orchards as well. Okay. So there's apple scab, which I don't see as much here down south, but I have seen it in orchards where they don't manage for apple scab. So apple scab causes a lesion on fruit here and on leaves, as you see here. As the disease progresses, we get what we call sheet scab, and then it causes early defoliation from the tree. If some of these early fruit lesions start to expand, they can lead to cracking on the fruit and larger lesions, as you see here, and this can allow other pathogens to enter. So we really need to focus on managing apple scab, basically from green tissue, when you start to see green tissue on the tree, through first cover. That's when these apples are most susceptible to primary infection, and then you want to continue to scout throughout the season. Okay. So how are we going to manage apple scab? So firstly, what I would recommend is really for a homeowner, stick to cultural control and sanitation. So you want to abide by horticultural practices that will promote fast-drying conditions. The longer the leaves are wet, the more severe an infection will be of apple scab. You also want to manage your leaves that have fallen from your apple tree. The apple scab pathogen, Venturia inequalis, can overwinter on leaves or does overwinter on leaves underneath the tree, infected leaves underneath the tree. So you want to try to mow those leaves, remove all the leaf litter, or even apply urea. There are some resistant cultivars available, actually 25 or more. Again, Gold Rush, Jonifrey, Liberty, Modi. These are just some examples of scab-resistant cultivars. Again, these are not resistant to other apple diseases, so be careful. There are some chemicals that a homeowner can apply. You want to do these on a 7 to 14 day application interval. I know Captan is widely available for homeowners. That's probably your best bet at controlling apple scab. There are some single-site fungicides, myclobutanol, which is marketed as Immunox, and the group 1 T-methyl. Be careful using something like T-methyl, though, because there is a lot of resistance in scab populations. Okay, I'm going to skip cedar apple rust just because I'm running low on time here and I want to address some of the summer rots, but feel free to ask me about cedar apple rust during the question section. Okay, so like I said, here in the south we have a number of rots that we have to contend with on our fruit. I'm going to talk about 2 of those quickly. Okay, so we have bitter rot, which I showed early on, and again, this you can identify bitter rot by the pink salmon-colored spores in concentric rings. And this disease will usually show up on mature fruit, and it can wreak havoc during post-harvest as well if you're not storing your apples in a refrigerator. If you cut the apple open, you'll actually see this V-shaped lesion extending from the surface of the fruit down to the seed area. So we call that the V-rot in the flesh. Unfortunately, most cultivars of apple are affected, even things like Rome Beauty and Red Delicious, which if you read the literature, they call them moderately resistant. However, I saw a lot of bitter rot out on Red Delicious here in North Carolina last year. Another rot that you need to be aware of is white rot. And I call this the applesauce rot, because if you throw the fruit on the ground and it explodes like you put applesauce in, let's say, a balloon or something. So to start scouting for this disease, you want to look for tiny red-brown spots around the fruit lenticels. And if you squeeze the fruit, it's going to have a turgid feeling to it. On red skin cultivars, or even yellow skin, they'll often take on a bleached appearance to the skin. And sometimes early on, you'll see a red halo showing up around the lesion. This pathogen can infect around petal fall or even 10 to 14 days after petal fall, but it doesn't show up, or the symptoms won't be apparent until 4 to 6 weeks prior to harvest. To manage your summer rots, there's a few steps you can take. First of all, this pathogen overwinters in mummies, as you see here on the left. So these are little fruit mummies that are more prevalent on some cultivars than others. And so removing these cultivars with pruners or just plucking them off with your fingers and removing them from your tree area will definitely help reduce the fungal population in your home orchard. Here on the right, these leaves are yellow because there was a canker in the scaffold. So again, the pathogen can overwinter in these cankers, so you want to make sure to try to cut these branches out and remove those. There are some chemical options as well. Mancozeb, if you can get your hands on Mancozeb, you can apply that until bloom. Be careful though, the breakdown products of Mancozeb can be pretty nasty, and so Mancozeb has a 77-day pre-harvest interval. Other options are Captan or thiophanate methyl. That you want to apply 10 days after petal fall, and then really you need to continue applying these fungicides on a 14-day interval. And with that, I think I'm done. And thanks for your attention. And please let me know if you have any questions.
Does this affect crab apples also?
So most of these diseases will affect crab apples, especially fire blight. So I haven't heard of much bitter rot on crab apples, to be honest, or any of these rots. But I've seen early season diseases on crab apples. So fire blight can be a nasty one because crab apples will often bloom earlier than your standard edible apple. So getting on top of that is a real rush sometimes, and it kind of hits growers by surprise on the crab apples. I've seen apple scab on crab apples and cedar apple rust as well, which I didn't mention. With the cedar apple rust, there are some resistant cultivars of crab apple that a homeowner could purchase. Okay, I've got a question here. Is there a residual concern with the use of streptomycin? So that's a good question, and I've heard this one before. No, we really haven't had any issues with streptomycin and residual effects. So streptomycin is not allowed to be applied. I believe it's 50 days prior to harvest. And by the time of harvest, we don't see any detectable residues on the fruit from streptomycin. So the likelihood of ingesting streptomycin at harvest, unless you do not follow label protocol, is very unlikely.
Any other questions? Okay. I don't see any. If you guys have any, I'll be glad. If she doesn't stay around, I'll be glad to pass them on. But thank you, Sarah, for all of the things that you've covered. I know that as an agent, that would have been excellent information to have, and I know the Master Gardeners will appreciate it as well.
Thank you so much, Lisa. I appreciate it.
Alrighty. Well, thanks, Sarah. That was great. Well, now on to some insects before Mike talks about some pathogens. And I start with this photo. It's not an insect, of course. But actually, does anybody know for sure what this is? We've been talking about what kind of plant this is. It looks like a taxacean. This is in my yard. It's kind of a U-type plant. Looks like we might think it's a cephalotaxis, but anyway, this part of my talk kind of started with this plant, and we were out in our yard, me and my wife, pruning this group of plants. They were growing like crazy, and I flipped it over and found lots and lots and lots of scale insects, these cottony scale insects, which I'll talk about a little bit more in a moment. And I was very surprised at how high the densities were, and I've actually been seeing a lot of this particular scale. This is probably Pulvinaria floxifera is the old name. I think it's Chloropulvinaria now, but it is some confusion in this group. It was so high, the infestation, that right below, within the bushes, the poison ivy was even getting the scales on it, which I don't think is necessarily too surprising, but a lot of people may think that poison ivy may also be resistant to lots of different pests. Well, poison ivy does get scale insects too. So what I wanted to talk a little bit about today, and I know I've gone out and spoken to a few Master Gardener groups recently, but especially for those who I haven't spoken to, and maybe a little bit more information for those who I have spoken to, I'm going to talk about a little bit on some scale insect biology. So this isn't necessarily going to be about identification of scale insects, but a little bit about their biology, how they reproduce and such. Now, there's a lot of variability in scale insects, so I may provide later on a link to a good resource from University of Maryland that discusses some of the specifics of certain scale insects that you'll see out in the environment. I would love to develop one for North Carolina as well, but it's just a very diverse group and lots of different life histories. So these are in the order Hemiptera. They're in the superfamily Coccidae. So these are the scales in general. They are in a group of Hemiptera with aphids and whiteflies and such. They're all sucking insects, although many of them suck from the vascular tissue, the sap. Some, like the armored scales, actually suck liquid contents out of individual cells. This actually is what results in them not producing honeydew, whereas others do produce honeydew. I'm not going to really be talking much about honeydew today, though. They do vary greatly in lifestyles and food sources. Some are very prolificous. Some are only found on specific plants. Of course, most of you know that they are characterized by a sedentary or largely sedentary behavior, or actually they don't really even have much behavior, a lot of them, especially when they become an adult female, like this scale right here. So some groups are on conifers, others are on monocots or dicots. There are many species that are actually on grasses. They're rarely on annual herbaceous plants. They basically need kind of a persistent substrate to breed on. If a plant dies every year, that's not long enough for most of their life cycles, because typically they overwinter and they need to then mate and reproduce the next spring or so. A lot of them. There are typically 3 nymphal instars. This is mostly for the females. You actually have an extra one in the males, which I'll show you in a little bit. And the first one is a crawler stage. So a lot of these sucking insects, especially things like whiteflies, have a crawler stage also. This is a very mobile, very tiny nymph that is either windblown. They've been known to crawl on the feet of birds and in the fur of squirrels and basically get distributed around like that. They do not have wings, so they don't get distributed that way. And actually, I had in a workshop we were doing earlier this week, somebody asked about how they disperse. Do they fly? Well, but scale insects cannot fly and disperse because the young stages are wingless. Now, there's a great variability in the number of eggs that females produce. Apparently, armored scales produce the fewest, about 50 eggs or so. But some scale insects can produce up to 8,000 eggs per female. Around here, I think I read a figure that some of the females and some of the larger females in the tropics can produce even more than 8,000 eggs. So they're very fecund. They produce a lot of young. So the first group will be some of the we would call primitive scales. These are kind of at the base of the scale tree. They are a little bit less scale-like. They often have many segments in their antennae. They have usually legs, well-developed legs and such. Now, these are the families that these are the 2 families that are commonly found in North Carolina, the Mealybugs and Margarodidae. Now, they both were formerly united in the family Margarodidae, but recent analyses have shown that they're actually fairly distinct lineages. Many of the primitive scales used to just be lumped, and now they're separated. So the Mealybugs contain the cottony cushion scales. These are typically on Fatsia, Nandina, and Pittosporum. Basically, a lot of the evergreen, exotic ornamentals, tropical ornamentals. But they're not a hugely common species on a lot of our native trees or anything like that. You're only going to really find them on these exotic ornamentals. And this is a cottony cushion scale here, which I'll talk a little bit more about in a moment. The Margarodidae, strict Margarodidae now, are restricted to the ground pearls, especially the genus Margarodes. Typically, these are found on warm season turf, and this is in the soil, actually, on the roots. Especially centipede grass, but St. Augustine grass, and a number of the other warm season grasses. Now, we do have a few other primitive scales that were before lumped in the Margarodidae. They're native to the U.S., but they're very uncommon and kind of specialized. So, cottony cushion scales, Iceria purchasei. This is a non-native species that was brought from Australia to the U.S. in the late 1890s or so, late 1800s. One of the interesting things here with this scale, and especially this genus, is they're actually hermaphroditic. Now, we talk a lot about, and we'll talk a lot about, parthenogenic females. These are females that don't need to reproduce, don't need to mate, and they basically reproduce with clones. But in this case, the females actually have sperm that they can self-fertilize with, which is really weird. Honestly, I didn't really even know about that until recently. Now males can be produced, but are very rare. I actually saw one. This Fatsia right here is out in front of our building. It always has a really great population of cotton cushion scales. One time I saw a male. I was so excited. I went inside and I came back and it was gone. And I really would love to take a photo of it, but they're extremely rare. Now, when the males mate with the females will produce some males and some females. But basically, without mating, they can kind of mate with themselves, being hermaphroditic. Now, these are mobile scales, fairly mobile scales, with overlapping generations. You can see some younger ones here with the larger ones, and I think there are even some much smaller ones around here. And depending on the temperature, they can have multiple generations per year, or they can take over a year to develop. Now, one of the things to note is that their main predator is a beetle that was imported to the U.S. called the Vidalia beetle. It's an Australian ladybug, and you can see here feeding on the scales. Another fly parasite was actually introduced into California, one of the cutest flies ever. I didn't have a photo of it because it's still just restricted to California. It has not spread with the cottony cushion scales. But anyway, a few natural enemies have been imported that kind of keep them in check. Typically, we don't see huge populations on plants. Sometimes, like this Fatsia, you get a lot existing population, but it's a little less than, say, the armored scales, which often encrust everything. So this feed on camellia. I am not sure. I personally have never seen it on that, but it's pretty generalist scale. It may. I wouldn't put it past it, but I really don't know exactly. I'd have to check. I actually should show you. There's a really great website. Let's see. Here, I'm going to copy it in there. So there's this really great website, ScaleNet, which if you search for a species, it'll give you a whole host list of the known hosts, the known geographic range, and some references for its biology, descriptions, things like that. So it may be on there. I would have to search. But again, it's pretty prolificous, so it may feed on it, but it's probably not very commonly feeding on it. Now, one scale we often don't talk about are the ground pearls. These are tough to identify as such, but I mean as a species. But in general form, they come in kind of two main forms. So you have mostly parthenogenic females right here. This reproductive pink female, and actually, if we go back, you can see they're very characterized by these. These are not fangs. These are actually the front legs that are hook-like. So if you find this pink scale-like insect with hook-like legs that's in the ground, that's a ground pearl. Now, what happens is the females dig somewhere, lay a bunch of eggs in kind of a waxy area, and then when the young hatch, they start to secrete this waxy kind of ball around them. It's like a little BB, and it can actually apparently range from a couple millimeters in diameter to over 4 millimeters. And they can be quite impressive. Now, even though this looks like some kind of armored thing, they've actually got the mouth parts that come out of it, and they tap into the roots of the grass. Now, one of the really craziest things is what the males look like. The males do have, again, also these very large hook-like front legs. This insect was posted on this macromite blog, and as a mystery, even to the blogger. And there were so many different crazy guesses as to what it is, and then they finally figured out that this was a male ground pearl. So again, fairly rare form. So mealybugs, the Pseudococcidae, there's a huge group of it's the second largest family of scales behind armored scales. Many that we have are actually subterranean. The native ones are subterranean on plant roots. So many of them are associated with ants. Now, I rarely see these as an issue in home gardens. They're typically more in greenhouse production where they can become really high populations. But this magnolia, for instance, was taken outdoors with these Fericea striped mealybugs. Now, they're somewhat mobile for scales. Even the fully grown females can wander around the plant, but very slowly. And of course, the best way to ID them is that they have they're covered in this mealy white wax with these little filaments all around them. And the condition and shape of those can be somewhat diagnostic, although you really do have to, if you're not quite sure, you really do have to slide mount them to identify them. Now, mealybugs are one of the groups that do also often produce a large egg sac. So here's a dried female, and here this is a natural egg sac, and then I broke this one open. You can see the hundreds, or I'm not sure how many eggs are actually in there in that sac. And this is, I didn't discuss this with the cottony cushion scales, but that cottony cushion that they have is actually an elongate wax pouch to hold eggs. So you can see that this will be a theme throughout a lot of scale insects. And actually, there's a term, the term for that white waxy pouch is called a marsupium, based on the marsupial kind of condition of having a pouch. All right, any good beneficials to kill mealybugs in greenhouses? That I'm not sure. I'm not sure which ones are good as far as efficacious. I would have to talk to somebody who works with that and has done trials. There are several different insects that will eat any general scale insects. Things like Aphidoletes, which are a type of gall midge whose larvae eat aphids, and also small, soft-bodied sucking insects, ladybugs, lacewings. But again, I don't know how well they work in the greenhouse. We'd have to talk to somebody who's actually done trials or see what are good. Mealybugs can be very difficult, unfortunately, because they do attain very high populations very quickly. And so sometimes things like insecticidal soaps or whatnot might help. But again, I'm not an expert on the control of them. Now, sometimes you'll also see cottony masses associated with mealybugs. Some actually are ovoviviparous, which just means, so oviparous means they produce eggs. Viviparous means they produce live young, that give live birth. Ovoviviparous means they actually produce eggs, but the eggs hatch so quickly and basically inside the female that it appears like they're giving birth. And so this is the long-tail mealybug is one of the members of the mealybug family that give, you can see here's a tiny crawler next to the mother, and that have an ovoviviparous lifestyle where you would almost basically think they give live birth. This is the one reason that they can very quickly infest plants. Now, you might see some little cottony pieces on plants associated with mealybugs, and that might be the rare instance where you find a male. So males are rarely encountered and very short-lived, only a few days. Here you can see a crawler, a fully developed male scale mealybug. I mean, it doesn't at all look like the females. It's got wings. It looks like a little tiny fly. And here, actually, I took out of this cottony kind of cocoon. This is a pupal male. So you can see it has well-developed legs. It's starting to have these wing buds, but basically it is not fully developed yet. If you look hard enough, you can find them, but it's really, the males are not an issue. After they've become pupae or pre-pupae, they're not going to feed at all. They're just going to mate and die. Okay, soft scales are a very important and very common group of scales. Actually, Coccidae, the family name, the superfamily name is based off this family. It was the first described, basically. Often round and shiny when fully grown and female. You can see this female is not yet fully grown, and you can see the male here mating with her. Once after he mates with her, she will develop the eggs and inflate and become very shiny and basically die covering her eggs. Again, the males are fly-like. In coccids, the male has this fairly distinct neck that'll be different than in the next group we talk about. There's typically one generation per year in soft scales. So they usually what happens is they mate in the spring, the late spring, early summer. The females bloat, fill with eggs. The eggs hatch. The crawlers then in summer or so start to crawl around everywhere, go out to leaves. They'll feed, and then they will molt, develop into a second instar, and then before the leaves fall, they will return to the bark of the trees, where then they start to overwinter. And then basically when they resume in the spring, they're going to start feeding again, getting more mature until they're a mature female, and the cycle begins again. So basically this time of year is when we're going to start to get the mating going on and egg and crawler production very soon after. And actually the crawlers are the stage that's best treated against. Again, treatments might be specific to the locality, things like that. So you'd have to consult with a specialist. And if you have any questions about specifics, you can always email me and ask me, and I can get you the right help. But yeah, the soft scales are basically about to start bloating now with eggs, and then we're going to see lots of crawlers. We actually had I put up on our Facebook page a couple of years ago. We caught the height of the crawler stage, and it was a particularly good year apparently for the eggs and crawlers, because you could see thousands of them crawling on the trunks of oaks. This is the oak licanium, which I'll show you in a second. Thousands of them crawling on the oak trunks, thousands of them crawling on the concrete below. Lots of ladybug larvae, ladybug adults, and predatory and parasitic insects running around, basically in this huge smorgasbord of little tiny crawlers. And so it does, thousands of millions of these things are out there. Probably billions, I guess. Now the females and coccids are a little bit more fecund. They have, thousands of eggs sometimes. But typically you got to look at the soft scales. This is just again a smattering of some of the soft scales that are out there. Again, I talked about this cottony pulvinaria type scale. I put it in quotes because, again, the taxonomy of that group is kind of confused right now. But this is probably also the cottony camellia scale or the cottony taxus scale, which are both pulvinaria foxifera considered traditionally. And again, it's got this white ovisac. What will happen if you flip this female over while she's developing the ovisac and or the marsupium and these eggs, you'll see she has legs and she's still alive. Once that's done, she will die, and basically the eggs will kind of do their thing, hatch, and start to disperse as crawlers. Charaplastes, the wax scales, are typically not in huge populations, although they can be, and they're typically on woody plants. Again, here's some large Tumiella, which in the late summer begin to really bloat and become huge and produce a lot of honeydew on things like this is a tulip tree. And again, this is the Parthenolecanium, or it could be a what is it? Yeah, Parthenolecanium. There's a few species on oaks. They're difficult to tell apart. If they're a little softer, I might be able to slide mount them and ID them, but once they become very hard and bloated, it's basically impossible to smash them on a slide. Now, male Coccidae, these are the pupae. So this is after the crawler has overwintered, or the second stage has overwintered, they will start to develop into these male pupae. So they look a little different than the females. They're kind of glassy. And inside there is going to be a developing pupa, and then it will develop even more into an adult male that will be winged, like I showed you before, just like a little fly. You can actually see some other scales here too. Okay, the last group, the armored scales. This is a huge group. It's the largest group of scales. Actually, some recent phylogenies, though, have shown that it may not be a monophyletic natural group. It may be a number of different families. The jury's still out on that one, and we really, we can consider these all families still, but there's a lot of craziness going on in the evolution and the taxonomy of scales. So the crawlers are unarmored, similar to the other scales, but then develop this thick test. I show this a lot, but this is one of my favorite photos. Basically, you have all these shells under the bark of an azalea branch, and if you remove one, you see the soft adult female there. So as they age, so the crawler has just regular skin, and you can see it's this little coin-like thing on the top of the test. Of course, it's on the top because it develops below that, and then starts to add and accumulate this type of shell on it. There are often multiple overlapping, sometimes literally, generations, and they typically creep up a plant. So the newest growth will have the fewest numbers, and they'll start to crawl up the trees and settle, develop, have their own eggs, crawl up the trees a little bit more and settle. So oftentimes you'll find many different life stages in the same vicinity, and some of them are just old scales that have died, and then others are the newly developing ones. Males are often in bright white pupae, so they have this little pupal case that you'll see in a second. So here's just a general life cycle. This actually applies to a lot of scale insects, but this is specific for armored scales right here. So basically you have an egg. It's going to become a crawler. You can't tell the difference between the crawlers. Even the first instar crawlers, they kind of settle down, and it's difficult to tell. Then you get the second instar. This is a female that's going to develop into a similar-looking third instar female and adult. Whereas the male will settle down, and inside there will be a developing, basically a feeding stage, but then develop into this pre-pupa, pupa, and then an adult male that is fly-like. Now, one thing to note with armored scales is that the males have basically no neck. They're very tiny, and they have this sword-like ediogus, or sex organ. Anybody want to guess why they have a sword-like one? All right, we'll see in a minute. I'll answer it. So, oh yeah, Mike, just one pair of wings. That's a really good observation. This is one of the interesting things about scales. Scale insect males only have one pair of wings ever. Their hind wings are actually reduced into these little hook-like structures called hamulohalteres. In flies, another major group of two-winged insects, they have the hind wings are called halteres because they're club-like. But in male scale insects, they're called hamulohalteres because they're almost like hook-like hamuli and halteres. And so actually in a lot of the keys, if you have a male scale insect and you try and key it out, you'll come across a similar path as you would to flies, because again they only have one pair of wings. But again, very reduced wing venation and everything like that. But good observation. That's really kind of an interesting thing. Sure, yeah, Allison. Yeah, well, I was just asking if anybody can think about why the male has that long sword-like ediogus. Because it works? It does. But why don't the soft scales? The soft scales don't have that. The mealybugs don't have that. If we went back, I could show that. But here's I'll show you that in a minute. I'll talk about it in a minute. But here's some armored scales. People have probably seen these photos all the time. I got to get some new ones. But you've got male and female euonymus scales in the genus Eunaspis. You've got this male and female minute cypress scale, Caryolaspis. You've got T-scales. There's males and females in here, Furinia. And Melanaspis, gloomy scales. This is a female. I have not seen gloomy scale males. It may be, I have to read, they may be parthenogenic. But I'm not sure exactly. I've seen males in a lot of the other scale insects. All right, we've got some answers. So yeah, so basically the male has this long ovipositor, or a long Ediagus, because he needs to mate with the female that's under that test. And so he basically has to stick it all the way under there to mate with her right here. And she has this vulva up here. It's hard to see in this picture. But basically he will insert that under the scale, the armor, basically. And interesting to note, you see a lot of these, well, Diaspididae is based on diaspis. You've got Cariolaspis, you got Unaspis, Melanaspis. Aspis is actually Greek for shield, and that is because, of course, these are armored or shielded types of scales. So again, coming back to this, this is a male T-scale, very, very tiny insect, only about 1 millimeter long, maybe even less. Here's a drawing of a San Jose scale, showing the difference between the male and the female. And here it shows more of those little hymulohalteres, these little tiny reduced hind wings. A female scale insect right here shows how large the eggs are. It also shows, which maybe people in the presentations before have not been able to see very well, but a parasitoid wasp larva inside the scale insect. Okay, so moving on from scales, if you have any questions, let me know. Just wanted to talk a little bit about the biology and how they reproduce, and some male versus female scale insects. I will post a link to that Maryland fact sheet. It does a good job of describing the biology of specific species. Again, there might be some differences because of Maryland's climate versus here. Not too different, but anyway. Okay. The next thing I'm going to talk about is another bug, except a much larger bug. So brood 6 is back. The periodical cicadas in the genus Magicicada, almost looks like magic cicada, and they are kind of magic because they have these weird prime number 17 to 13 year life cycles. So this is actually the 17-year species. Of course, it was last seen in the year 2000. I'm assuming you all can predict if they're emerging this year, when they'll emerge next. If not, I can let you know, but maybe keep it a surprise. But these are going to be mostly in western North Carolina. So it's going to be, there you go, somebody do the math, 2034. Seems so far away. We'll have, flying cars by then. So so the two main species that are going to be emerging right now are Magicicada septendecim and Magicicada septemdecula. There's a possibility of Magicicada cassini also, but typically it's going to be those previous two species. Again, they're going to emerge in very large numbers for a short period of time. Basically, you have a couple weeks, maybe, of activity, and then they're going to be gone after they've laid their eggs in the tree branches. They're going to be gone until those young develop for 17 years. So pretty interesting. I don't know. I'll tell you a website you can go to see. I forget when the next brood is coming out in North Carolina. It won't be brood 6, of course, but it'll be another one of the broods. Now, how to tell the difference between the two major species that are going to be here. So decim versus decula. Decim is going to be larger. They have a little bit of overlap, but basically decim is going to be 27 to 30 millimeters long versus 20 to 28 millimeters long for decula. Decim has this orange behind the eye and in front of the wing, whereas decula does not. It's going to be black. Lastly, decim has these thick orange stripes on the belly, on the underside of the abdomen. Decula has very thin ones. Now, I mentioned cassini. Cassini is similar in size to decula. It does not have the orange like decula, but it also has a completely black belly. So if you see any orange, it's going to be probably, there's a lot of variation, honestly, but in general, these are going to be the cases. Okay, so time for you to tell me, have you seen any periodical cicadas? So select your check mark or X and put it on where you are, and let's see if anybody's seen that. Let's see. I haven't seen any here. The 17-year cicada actually has grouped areas, each area hatching in different years. So just like 5 o'clock, you get them somewhere every year. So there are different broods all over the place, and there are some disjunct broods. But basically, most years there's a brood that falls on it, and the broods can be made up of different species depending on where it is, and it's pretty complicated. So basically, I'll show you the website. That's a really good one on showing what's happening this year. It'll predict when they're going to be on other years, and basically you can go there and read about all the different broods and species. Because there are, again, 13 and 17-year cicadas, so there are some, and sometimes there are overlaps. It just happens to be that you'll have years where there might be overlaps. Okay. Well, we got one people seeing. Now I should note that these cicadas are typically fairly early in the year. We're going to get the dog day, the big green dog day cicadas, the annual cicadas later in the year. Again, the periodical cicadas are black with red eyes and amber-type wings, and so they're pretty distinct. In the western U.S., there's a couple species of cicadas that look similar, but don't quite look like a periodical cicada. Of course, also the huge numbers emerging will be indicative also. All right, so we've only got a couple of sightings from the people that are joining in. So Amanda Taylor sent an email showing some pictures she took just last week, and so they're definitely that was in Iredell County or around there. So they're emerging, but okay. So here is where this brood 6 has typically been found. So if you find some some cicadas and can take a photo, you can go to a website and actually document this current year where you found them, and that can help guide the data for maps in the future of where they're emerging. But again, North Carolina is actually an interesting locality because being in the middle of the Atlantic, basically they say 17-year cicadas are typically more northern, 13-year cicadas are typically more southern. We're right in the middle, so we get a nice mix of all of them, and so we are often subject to their emergences, whereas in other states you may only get one emergence, say, every 17 years, and you really don't get much in between. So discussing about the overlap of their emergences, North Carolina is in a pretty prime spot for it. Another thing to note, too, is that we are special in the world because this periodical cicada genus and periodical cicadas in general are only found in the eastern U.S., in the entire world. So it's pretty cool. Now, for more information, so some consequences of the mass emergencies, though. There are some things that you may be concerned about a little bit. The first thing is that cicadas in general are the loudest insects in the world. Thousands of individuals being the loudest insects in the world can be a nuisance sometimes. So you're going to hear a lot of noise from these insects. And they actually do have, you can go to the websites and see their specific calls. The males actually have a specific kind of alarm call and then also a mating call. And there's some clicks and different types of sounds that they make. There could be lots and lots of holes in the ground, especially at the bases of trees, because the nymphs drop from the twigs where their eggs were laid and go burrow into the ground and tap into tree roots and grow over the 17 years. When they come out, they're very large, of course, and they make a lot of holes. Now, that could be a benefit, actually. This could increase percolation and aeration of the soil. Lots and lots of dead cicadas. Once they're done with all their thing, there's going to be a lot of dead cicadas everywhere. Now, birds will take care of a lot of them, and other organisms will eat them, but just be aware of that. And lastly, a little while after they're done, you're going to have the damage from their oviposition. So you can have flagging of branches where basically lots and lots of these cicadas have sawed into the twigs, laid their eggs, you know, gone their way and then died, and then basically that sawing damage causes flagging of branches. It can be severe, but typically on very healthy, especially mature plants, they're not going to be affected by this. It's kind of a natural pruning. And again, if they don't emerge in your area anytime soon, you're not going to have repeated flagging year after year. All right, any questions about periodical cicadas? Cicadas are one of the more popular insects, thus I'm not an expert on them. I like the weird, obscure things more, but there's a lot of information out there. And actually, this is the website, this magicicada.org. A really great website talking about, with maps, talking about the different species, behaviors, some interesting things. There's actually if you note here, this link says fungus infections. There's apparently this weird fungus on cicadas that affects them, so sometimes people find these whitish ones. Anyway, feel free to visit magicicada.org to read more about them. And if you don't have any more questions, I'm going to just talk a little bit about what you should be on the lookout for. Oh, whoops, I forgot. Hey, here's a quiz. Can you type the website? Okay. .org. That should do it. Well, I'd have to search the actual, but it's basically yeah, magicicada.org. If you put that in, you should find it. All right, so here's a little quiz. This is how many different organisms are in this image, referring to this large image. Here's a zoom out to show you what the situation is. All right. Well, let's clear this. Can we do a number, Mike? I'm not sure. Let's see.
Well, they can either put in the text, the text tool there in the middle of the tools bar, or else, of course, type it into the chat box.
Okay. Yeah. So how many different organisms do you see in this big image? Let's pretend that these leaves back here are not from any other plants. Okay, so we got 4. Let's see. Okay, anybody more than that? Less than that? 6. We've got 6. 4. There are probably more than I can count in this photo, but kind of just the obvious things, and then kind of one more obscure thing, kind of. Okay, so we've got 4 and 6. Okay, now I had only a certain number in mind, and then I said, oh no, these people are gonna get a couple extras that I wasn't thinking about. So 6. All right. Well, I'd like to hear about what some of the other ones were, but I got 5. Now I should say some very astute person is going to say, well, lichen is technically 2 different organisms, and there might be a couple different species of lichens here. But what I wanted to get at was we got this picture in, and it's very interesting. So we've got the oak, that's the host, and on this oak was a big brown patch of felt fungus. Now, felt fungi are only associated, they can be black or brown, they're only associated with armored scales. They live in this mutualistic kind of relationship with armored scales, where the armored scales apparently receive some protection and also get parasitized by the Septobasidium felt fungus. So we can then assume that there are armored scales under here, relating to what we talked about today, But also, one of the very interesting things is that, especially on trees with gloomy scales or many scale insects, you get these little orange fruiting bodies of another fungus. This is a totally parasitic fungus known as either Nectria or Cosmospora or Cosmospora. Now, of course, I had been done counting there, and then I say, oh, well, yeah, there are lichens on the tree, so I can't give up there. And if we count the 2 organisms in the lichen, then 6 would be correct. So 6 is good. 6 is perfectly acceptable. I'd be curious to know what other people saw a little bit of. Maybe there's another thing in that picture that I couldn't see that I didn't mention. But anyway, I thought this was a really interesting picture we received because not only did it show this kind of weird mutualistic fungus with armored scales, it also showed the parasitic fungus of the armored scales popping out of that other fungus. All right. So, be on the lookout. May and early June, of course, we're going to have another PPP at the end of June. We're in May this time, different than typical schedules just because of schedules. But bagworms are going to start hatching very soon out of the eggs from their mother's bag. And this is a very tiny bagworm you can see. It's only about the size of a needle on this arborvitae. And so they are very small right now. They will be once they hatch. So if you suspect you might have bagworm infestations or had previous ones and you want to protect your trees more, this is the more susceptible age of the caterpillars. What you can do is try and beat the plant branches onto kind of a sheet of paper or a sheet, and you'll see these little bagworms perhaps on there. And that'll tell you that you've got little bagworm activity. There will also be, of course, other caterpillars. I just saw an egg sac on the door of my child's preschool that had all these holes in it and very tiny, tiny caterpillars on it, which I'd like to go back and sample. Another thing, young bugs. So, anybody want to tell me what these are? So this actually, I saw one of these, the adult of one of these, starting to lay a line of eggs on the screen of my screen porch the other day. We were out there eating dinner. Wheelbug is a good guess, but that's incorrect. This is the confusing one. This always gets confused. It's not. It's very often confused for wheelbugs. These are actually leaf-footed bugs. So these are coreoids. And again, I talked about this a few sessions ago. I'm not sure. Wheelbugs will be black on the head and thorax and red on the abdomen. The wheelbugs will also be more front-heavy. You can see the hind legs on these specimens are bigger than the front legs. It's reverse for the wheelbugs. Oh, yeah, I forgot the yeast. Okay, yeah, you're right. So, yeah, the new research has shown that the lichens are 3 organisms, not 2. Yeah. Oh, although, actually, I think they found that they're not sure whether all lichens have that yeast yet. But anyway, that is a really cool story from last year that researchers found the extra organism in there. So 2 types of fungi and 1 type of plant. Okay, thanks for the clarification. All right, May beetles, of course, is May, so May beetles. We have seen some of them. I have seen some of them earlier emerging ones come out earlier in April. But we're going to start to see these brown, chestnut brown or reddish brown beetles swarming lights and emerging. The larvae, of course, were in the soil feeding on either grass roots or detritus, things like that. They are harmless. They don't actually, unlike some other beetles, particularly the next one, they don't feed as adults really. Now, Japanese beetles will also be emerging, and they do feed on plants, of course. And so you'll see a lot of them mating and feeding on things like roses and other softer plants, basically. Especially Rosaceae they prefer, but they'll feed on all different types of plants. Vegetable pests will be emerging and becoming very active. Here's a striped cucumber beetle, and these are cross-striped cabbage worms. So again, at this time of year, you're going to start to see a ramping up of feeding on the herbaceous materials and the vegetables in your vegetable garden. Galls galore. There are a lot of galls either starting to develop or already developed and kind of becoming their maximum, the height of their development. Either by, this is a gall wasp gall on oak, and this is a phylloxeran gall. You can see the queen, basically queen in quotes, they're called the fundatrix, that has infected, basically cause a gall in the bud of the leaf on hickories. The plant tissue grows around it. She becomes bloated with eggs that she'll produce and make a colony inside there. So they're just developing or starting to ramp up. And of course, as some of you know, you've probably already been bitten by either ticks or mosquitoes, so watch out. Be careful out there, wear repellent, or for ticks, you can, if you know you're going to be working in an area where there's a lot of tick pressure, make sure to treat your clothing and shoes properly using the instructions with permethrin. That's a good control for ticks that are trying to crawl up on shoes and pant legs, things like that. And with that, I'll take any questions, then Mike can take it from here. Yes, fire ants too. I was going to put that on there. They are ramping up their activity. Honestly, a lot of insects right now are kind of ramping up their activity. It's consistently warmer now. We're going to see a lot of activity from all different types of insects. Maybe I'll have to put that on next year so the bolo can kind of switch up every year. It's easy to repeat the same things all the time because, you know, certain times of year are conducive to certain types of organisms. But yeah, be careful of those fire ants. All righty. Well, Mike?
All right. Before I'm sure people's brains are probably full, as is mine. I'll give you a quick break here. I have to add a couple of quick things here to mine, but I want to put this link in here to the chat box. Matt's usually more on top of the news than I am, but I think you'll find, those of you who can click on that link and go to it, you'll find quite interesting the story that was in the New York Times last week, and apparently got some comment on it. So I'll let you do that and take a quick breather. This should only take me about 60 seconds to fix or add what I need to add here.
Oh, and here's that link to the Maryland scale insects. It's a very nice publication on some of the general, a lot of the specific species, but across different types of scale insects. I didn't talk about a few of them, maybe the less common ones I didn't talk about this time, just for time's sake. But anyway, that gives you some information. I would love to put together one for North Carolina too, but it should apply largely to us. So.
Well, this may not work like I wanted it to. Let's see here. Give it one more try. No. Okay, not going to work. All right, I had a mystery slide I was going to tack onto this presentation to start with, but instead we'll just go with the way I had it set up before for current diseases, and with the question, do you notice a pattern here? And that, of course, on several levels, I'm referring to the fact that if you've been a regular on Plants, Pests, and Pathogens, you may have seen some of these diseases and some of these even slides before. I believe in recycling, but try not to do it too often. And also, I'm falling into a new pattern this year where I've talked about certain groups of diseases or pathogens. So you remember last time I did this long digression on anthracnose diseases and anthracnose fungi, and it turns out that this time is no exception, and I'm going to do an extended presentation on another group of plant pathogens. So let's first of all, I assume that people are hearing me, but give me a green check if you would, if you can hear my voice. All right. See, 10 people can. I guess that's a quorum. Now, give me a green check if you've ever heard of a TV program called Mystery Science Theater 3000. Or Red X if you haven't. That works too. All right, you see we get a lot of MST fans. It's definitely worthwhile. I heard that Joe was trying to do a Kickstarter campaign and get some money to make some new episodes. I don't know if that ever worked or not, but there was a wonderful moment where he got a letter, was reading a letter from his fans complaining that 2 Gamma films in a row was a little bit excessive, but he said, well, the 3 Gamma films in a row is a Gamma Film Festival. So we're going to, I guess, follow a pattern here and talk about several within the downy mildews. But first I wanted to talk about several within another group and see if you recognize it. If you're a repeat customer, then you will probably know what this is. So either type into the text box. Oops. If you can either type into the text box or onto the whiteboard here using the text tool if you think you know what this particular disease is. To the slides, Mindy has a message here. I thought I've got the slide. Okay, yes.
It's up now.
Got it.
Let's see.
Yes, the host is Azalea. So anybody who's not Marshall want to say as what the cause might be? Could it be a mite or a phylloxeran or a bacterium? What might it be? No other takers? Okay, yes, in fact, it is a fungus. Galls can be caused by many things, but in this particular case, this is Exobasidium leaf gall on azalea. The basidium is a term that's used for a club-like cell that is where certain fungi, a large group of fungi, produce their sexual spores. And exo, of course, means outside, and this particular fungus produces its basidia on the outside of the gall. You can see the kind of whitish sporulation there happening. And we should be seeing these here soon. I don't know if anyone has seen them already, but they will be coming soon if we haven't already. Of course, the other familiar one, oh, I'm sorry, just another slide here to show that these structures on the azalea were not solid, they were hollow. So there's a little, what is that, Matt, a firefly hiding out inside the cavity there.
Cool. That, yeah, maybe if, ooh, that's tough. There might be a soldier beetle or something, but that's a weird one. And actually, just a side note then, a lot of insects are inquiline in galls. So you could have a gall that's made by another insect or arthropod or fungi and things like that, and other insects will invade it and feed in there kind of opportunistically.
So right, and this obviously this beetle did not cause this gall. Here's the other big one we see, the Exobasidium, different species that causes a leaf gall on camellia. These large, pale, fleshy galls. You can slightly see the resemblance to what would have been a leaf, and on the underside, the white, fuzzy, very slightly felty sporulation of the fungus itself. Now with time, some secondary molds get on there, and you see this darkening here. But that, by the time you see it, the white spores of the fungus had been produced already, which is important when we talk about control, because what you need to do in these cases is simply pick off the galls, but before they produce their spores, and I'll say why in another moment. This, of course, as a springboard to a couple of pictures. The reason I'm including this in this presentation is because we got a couple of image samples into the clinic that were similar, and you would definitely suspect an Exobasidium type gall. This one came from Bertie County last month. Billy Barrow, let me check and see if is not on the session right now, but had submitted these particular images, and this was submitted though as buttonbush. Well, I was suspicious that it was something else, and by looking at Chuck Hodges actually contacted the agent to make sure that that was a correct identification on the host, but I was pretty sure that it was not correct because, as you can see looking closely, the leaf arrangement on this particular plant is alternate rather than opposite, which it would be in buttonbush. So I'm suspecting that this is something else. And oddly enough, we got, so that was Bertie County, we got another sample here of a very similar structure from Edgecombe County. It just came in yesterday or the day before. No, but anyway, within the last couple of days. And I suspect that this is going to be the same thing, even though we didn't have a good host ID here, but it's Exobasidium symplosi. And the host, and we know this because it came up last year, and Alexander Krings helped us to get the host identified. The host turned out to be sweetleaf, yes, or horse sugar, another common name. And I think what happens is if the picture here, which is very nice, holds true in general, you notice how that first growth is coming out at the very tip of the branch, whereas the flowers are in the axils here lower down. And so that is probably why you get the type of gall that you do on this portion of it. And let me see, the agent had asked a couple of questions. This one was going back to Billy Barrow's submission. He asked the questions, galls on limbs and twigs, is this common? Well, apparently more common than we thought, since it came up twice within a couple-week period of time. Second question, is there an alternate host? And no, there is not. This would just be infecting the Symplochus in this case. The life cycles of these are typically that the spores produced now, the basidiospores, the sexual spores, are going to blow on the wind, and where they land on the new buds of the plant, they will either lay dormant there or initiate an infection and then lay dormant until growth resumes in the following spring, when the fungus itself also resumes growth and produces this gall. Now there are some variations on that life cycle, but that's the basic pattern. And so since it's only producing its spores at one time during the year, or in a short interval during the year, you have the opportunity to pick those off if you catch them in time before spores are produced, and then reduce the inoculum for the following year, breaking the life cycle that way. The group of plant diseases that I wanted to spend more time on today was the downy mildews, and this is also inspired by a couple of recent samples, which I'll mention later. But we need to make sure that we're clear on the difference between the downy and the powdery mildews. First of all, the downy mildews will cause a variety of symptoms that we don't often see with the powdery mildews. Now remember, a symptom just refers to the way that the plant presents some kind of a change in color, shape, cell death, and that sort of thing. In this case, you can have them on leaves, stems, or flowers. You'd almost never see a downy mildew on underground plant part. And they can be in the form of either necrotic spots, as you can see on the picture on the left, or chlorotic spots, as you can see on the picture on the right, and they are often angular. So you notice that this spot is somewhat defined by the veins, as are these, producing kind of an angular look to it. Now when you see angular spots, just in general, you want to probably think of three things first, and this will cover about 90% of the causes of angular spots on leaves of plants. One would be downy mildews. Another would be bacterial infections, and those often will have a water-soaked appearance when held up to the light. And another would be foliar nematodes. So if you suspect those three things, when you see angular leaf spots, you'll be right probably, I'd say, 90+% of the time. The third thing that downy mildews do, and is a reason why they're so serious, is that they cause defoliation of the plants. The leaves will drop off. These are, we could say, ecologically they are fungi, but they are not true fungi. So in the evolutionary scheme of things, they are not related to other fungi. In fact, the fungi, the true fungi, are more closely related to animals than they are to these oomycetes. They do occasionally produce, well, more than occasionally, but you won't always see them, signs. In other words, the actual fungus that you're seeing on the plant. And it is going to be a whitish or gray sporulation that will only occur on the underside of the leaf. So you can see some of it here, and you can see some here in this picture. And I'm deliberately not saying what plants these are yet, because I want to ask that question of you in a moment. The pathogens themselves, they're all in the same Paranospirales, the same order, but there are several genera. What used to be just Paranospora is now broken up into Hyaloparanospora, which hyalo just means clear because the sporangia are clear, and Pseudoparanospora, as well as other genera like Plasmopora and Bramia, which I haven't seen here in North Carolina. These are host-specific, so the two important points to take home about them are that they are not going to be jumping on a whole range of plants. The downy mildew on one host, or at least host family, will be fairly specific to that family. The other important thing about their ecology is that some of these will overwinter here in North Carolina, but others won't. So you will not be necessarily having them at the same time of year each year as with some other diseases. So make it a little bit interactive here. If you could, those who don't have a mobile device that you're on and have use of the text function, you can click on that and then onto the whiteboard itself and type in the name of as many hosts as you can think of downy mildews. If you're on a mobile device that doesn't have the ability to interact with the whiteboard, just go ahead and type it into the chat box down below, and I'll go ahead and copy it. Okay, so great. Basil and cucumber. And sunflower. These are all good. Keep them coming. Yes, other cucurbits besides cucumber, good. Daisies, daisies, daisies. I have not seen it on daisies. Impatiens. That's good. Squash, okay, so other cucurbits are in there. Zinnias, I have not seen. I've seen a lot of powdery mildew on zinnia, but I have not seen downy mildew on zinnia, although on some of its relatives I have. All right, good. So you're familiar with the big ones. And I went back to the, okay, coneflower echinacea. I have seen it on Rudbeckia, but not echinacea. But there could be one on that host. I am not sure. I am actually not sure of that. I can check in a minute. I went back in the clinic database, going to January 1st, 2008, up to the present, and it turns out that there were a total of 225 confirmed or suspected downy mildew diagnoses at the PDIC during that period of time. Now this data, set of data, is not cleaned up, so I don't know. The majority should be things that occurred in North Carolina and were confirmed, but there could be a few other odd things in there that you might want to ignore, but this should give the story pretty well. Notice that half of those are between the cucurbits and brassica. Nobody mentioned that, but things like collards and broccoli also get a type of downy mildew. But the cucurbits are the biggest section, and the vast majority of those are going to be on cucumber itself, and we see that a lot in commercial production, but it does occur in home gardens as well. Nobody mentioned rose, I don't think, in the last slide, but that is also an important host, but not one that you'd worry about necessarily for your homeowner clients because it's very specific to the cool, very moist conditions of the spring in our nurseries. The only time I've ever seen downy mildew on rose on a landscape plant is one that was recently purchased from the nursery. So the ones that I would say, let me get the highlighter here. So the highlighter, it looks like it. The ones that you want to be aware of for the folks you're talking to will be cucurbits, brassica also, the cold crops, although it's not their time of year. Someone mentioned basil. Yes, this can be a very destructive disease on basil, both in the greenhouse and out in the landscape. Grape, as was mentioned. Probably not going to deal too many people with soybeans, hops. Coleus, probably more in the greenhouse situation. Impatiens is an interesting case, and I'll show a picture of this. We have not had an impatiens downy mildew sample in the clinic since 2013, after such a huge year in 2012. But then, of course, nobody wanted to plant impatiens, and nobody wanted to sell them. Now they're kind of creeping back into the stores, so it'll be interesting to see if people get onto the impatiens bandwagon again, and whether they get hit by downy mildew. And cereals probably would not necessarily see that in your situation. So these would be the big five probably for the folks that you deal with. Be aware that they can occur on the cucurbits, the cold crops, basil, grape, and impatiens. Now for a few pictures of these. Of course, on cucumber, that forms very bright yellow angular spots that then turn brown. The spots are less angular when you see them on squash or pumpkin. Now this is a disease you should send into the clinic, first through your extension office of course, if you suspect it. And the reason for that is because there's actually a website that keeps track of this disease for forecasting purposes, and I'll show you the link to that in a minute. If you were to look at the underside of this leaf, you might be able to make out just a little bit of the sporulation, but it's not terribly obvious, so that's why we want to put it under the microscope and confirm it here. You can actually keep track of where this disease has been reported in the United States. Right now things are pretty quiet, but we usually expect to see this sometime in June arrive in North Carolina. It could be early June, could be late June, but that's the time frame that it arrives here. And just a few pointers for the cucurbit downy mildew management in the garden. Buy only healthy transplants. The forecasting, that website that I just showed you, is something that's only going to be the forecast of what happens by aerial transport of spores. So anything that's moving in transplants that people are buying inadvertently and planting into their gardens will not be detected by that. Excuse me. Plant early while the season is young and maybe get some your fruits start to set before the disease moves in. Avoid overhead and late day watering, which will of course encourage any fungal and bacterial diseases. You can try fungicides, but they're going to be of limited effectiveness. The only ones that really would be any good at all and also available to the homeowner would be chlorothalonil and then some of the fixed coppers. Our commercial producers have a lot more at their disposal than the homeowners do. So once you've got it started, it's really going to be a losing battle, unfortunately. If you're getting a lot of leaf loss and the sun scald on the fruit, you can harvest early and look at the possibility of resistant varieties. I haven't checked into this lately, but there were a couple of things out there. Burpee had a couple of things, and let's see, I had it written down here somewhere, but this has been a couple of years now. Yeah, Burpee had 1 melon and 2 cucumber varieties, and Park had 1 cucumber line. Now there may be more now, but let me also put in here for you the link to the cucurbits page on the Extension Plant Pathology portal. And if you go there, you'll see down at the bottom there are links to some tables from Cornell of cucurbits with resistance to different diseases. But you'd have a hard time finding something available to homeowners on that list. And I looked at the list too for pumpkins. We planted, this is the first time in this millennium, so going back to before brood 6 was last out, that I have put pumpkins in the garden. And I see that there are absolutely no pumpkin varieties with resistance to downy mildew, so I hope this one stays away this year. You mentioned grape, and we talked about this on Plants, Pests, and Pathogens before, the oily sort of spots on the upper surface of the leaf, and then the sporulation on the underside. This is something that you're going to worry about on your vinifera grapes. Our native grapes, the Concords and the Muscadines, have high levels of natural resistance. Here is apparently 2012 was a good year for the pathogen, a bad year for grape growers. We had this example from Chatham County that year in May already. And it can cause fruit infections when the fruit are very young. So once they get to a certain size, they're no longer susceptible, but obviously you can get things moving in there into that damaged tissue. Downy mildew on basil is different. That's a Peronospora, so it was a Plasmopora on grape. This is a Peronospora, and you can see the dark grayish, bluish gray sporulation on the underside of the leaf. This was from October of last year. And here's a picture going back to 2012. Paige Burns had taken this. Paige, are you on the show today? No, I don't see her on there. But this is typical of what downy mildew will eventually do to impatiens, where it'll completely defoliate them, and then those stems will just turn black and rot away. We had underneath our deck on the north side of the house a beautiful stand of impatiens that would seed themselves and grow back every year, and since that epidemic they have not come back. I'm tempted to plant some in there just to see what would happen. Right now though, we've got a lot of nice ferns there, so I'm not complaining too much. Here's what the sporulation looks like on the underside of the leaves on downy mildew. It can be quite thick. The pathogen in this case is a species of Plasmopora, Plasmopora obtusans. And here are the samples that were the inspiration for talking about downy mildews today. This is from a greenhouse in Mecklenburg County that came in maybe 2 weeks ago. And notice that they're somewhat angular spots, but they're very blotchy. And they had appeared quite quickly over the weekend. The grower was concerned. I had to put them in incubation under cool temperatures, and sure enough got the sporulation to prove that it was downy mildew. You notice also here it's following the veins a little bit, and so it wasn't completely typical for the angular type leaf spot. This was some coleus that was brought in yesterday by Dr. Brian Whipker, who had visited a greenhouse here in Wake County. And again, very splotchy looking, somewhat angular. I think he was concerned that he had foliar nematodes, but it turned out that this was downy mildew, and you can just barely make out this purple spot is just the coloration, the symptom on the leaf, but you can just barely make out some of the little fuzz here of the sporangiophores, the sporulation of the downy mildew on that underside of that leaf. Finally, someone mentioned sunflower. Rudbeckia gets a similar species of, again, this is a Plasmopora, and it is systemic in the plant, so infected early in the soil, and it can move up and form these rather interesting patterns on the foliage, and of course cause stunting of the plant in this case because it's infecting it systemically. Arbolo, moving right along, unless somebody has any questions about the downy mildews. Okay, be on the lookout for. This will be coming to a calorie pair near you, maybe not this severe, both the fruit and the stem infections. It is rust, and it is, as far as we can tell, quince rust or cedar quince rust. So this is something that alternates with the junipers, and the actual gall on the juniper is not as dramatic as we get with cedar apple rust. It's just kind of a swelling, and it does have the orange gelatinous telia on it. Those are come and gone, and the symptoms that will be developing and the signs on the pear trees and some other hosts will be occurring in the next several weeks. Now, why would I put a BOLO quiz in May of a sample that came in September? This one, I don't remember why, but there was some reason I was particularly curious as to why folks didn't recognize this disease now. So this is sometimes called annual vinca, technically more properly called Madagascar periwinkle. Very popular, heat-tolerant annual bedding plant. Does anybody know what this is? While you're thinking, I'll read to you what the submitter had written. Quote, recurrent problem late summer to fall, around mailbox. I think probably the mailbox didn't really have much to do with it. Pansies also dying back, but some not as severe as vinca. Watered regularly. Replaced with commercial topsoil in spring. Plants along street, curb, all died. Plants that get less heat and sun are less affected. Anybody know what this is? We have wilts, we have root rot. Anybody want to try and be more specific? Nope, not dog urine. And not bacterial. Anyone else? Give it one more shot. Street cleaning? No. All right. I guess this disease doesn't get as much press as it used to. But this actually turns out to be Phytophthora. In vinca, in Catharanthus, you can get both a root rot and also stem infections. So in this case here, we can see a nice slide here from the old Plant Pass Flight collection of an early infection on a stem of this Madagascar periwinkle. And you can get the leaves looking like this. It doesn't get, you might also see something similar with Rhizoctonia aerial blight, but that's much less common, and the leaves would be more matted together by the mycelium. Here they do kind of wilt and stick together, but not in the same way. And petunia is another host. The wave petunias seem to be particularly sensitive to it. And it turns out to be the same species on Madagascar periwinkle as gets on boxwood and causes root rot there. How to manage this disease? Start with healthy transplants. Make sure that you always do that. Inspect those carefully, including the roots. Plant in raised beds so that you get good drainage. Mulch the beds, and I'll show you why in a moment. Avoid excess watering, which may have been the case with the previous homeowner. And grow something else. If you've got the soil once it's contaminated, it's going to be there indefinitely. So check out our publication AG 747 for tables of suggested plant species to grow where Phytophthora has been diagnosed. And the reason for mulching here, this is a slide that I inherited from my predecessors, and not sure if the photo was Mike Benson's or whose it was, but you can see all of the blight in the lower canopy of the vincas where the water, driving rain, or irrigation has splashed the sporangia out of the soil and onto the foliage where infection occurred. Quickly then, our bolos for May through June in the disease world on ornamentals. If you haven't seen black spotted rose yet, you probably aren't growing a susceptible variety. Phytophthora root rot on any number of hosts. Powdery mildew will be starting to come onto its own. Oak leaf blister. The photo in the far right here shows some old blisters have already turned dark and necrotic. People sometimes think that it's spreading at this point, but no, it's not going to spread any more than what it's already done now because the infections only occur once. But they start out as a light green and are less noticeable. Quincerescent ornamental pear, which you already mentioned, leaf spots and anthracnosis on maple, and rose rosette virus. There was a question here. I'm sorry, go back on the Phytophthora. Does it affect chrysanthemum? I don't think so, not at least that species. The My experience, though, in the home garden is that there was like a Shasta daisy or one of those, or a Nippon daisy that we had that seemed to have gotten it, but I never actually proved that. But I don't think chrysanthema would be a host. For our fruits, be on the lookout for peach leaf curl, peach scab, which you see pictured here, which is an early infector on the fruits, fire blight on apple and pear, as Sarah already talked about earlier in the program, and cedar apple rust, which will have its phase on apple coming up. The vegetable garden, bacterial spot of tomato and pepper, especially if you weren't careful with those transplants. Root knot nematode on any number of vegetable hosts. Late blight of potato and tomato, that's looking a little bit farther down the road. Hopefully it won't be a problem on tomato for quite some time. And starting late May onward, be on the lookout for the downy mildew on cucurbits, which you mentioned earlier, and southern bacterial wilt. In the turf, spring dead spot would be something on your Bermuda zoysia, your warm season grasses. As the temperatures heat up and the humidities, we'll see large patch on our warm season grasses, and brown patch on the tall fescue. A large patch of warm season grasses would be something more in the cooler times of the year, which we seem to be out of. And then, of course, fairy rings on any kind of turf grass. Oops, sorry, that was Lisa's slide here. So are there any questions? No? Then let's roll the closing music here, courtesy of Steve Bambera.